Hey guys, good morning. Go ahead and pause the video and try this warm up, and then when you're ready, unpause it and we'll talk about our answers. All right, so for the first one, here is our reference angle. So I got to label my O, H, and A. So here's H, O, and A. So I want to use A and H, so I'm thinking cosine. So let's do cosine of 48 degrees is equal to A over H. All right, I want to find cosine of 48 degrees. Don't forget you have to check to make sure you're in degree mode though, which I just checked I am. So cosine of 48, I get this decimal, it's like 0.66913, so on. But I know I'm going to multiply by 38 on both sides, so I'm just going to do that right away in my calculator. I end up getting, if I round to one decimal place, I get that x is 25.4 units. Okay, so if I look at letter B, okay, theta is my reference angle. Anytime you see that when it looks like a zero with kind of a line through it, that's theta from the Greek symbol for O, basically. So here's my H, my O, and my A. So I need to use the 20 and the 83 because I can't have too many unknowns. So since I want to use O and A, I want to use tangent. So tangent of theta degrees is equal to O over A. So in this case, I don't know what theta is, so this is that option we recently talked about where I'm going to do the inverse on both sides. So that goes away. So I just get theta degrees is equal to, and then I want to type in the inverse tangent of 20 over 83. So don't forget when you're typing this in your calculator, check to make sure you're in degrees, which I already was, so we're good. And then also make sure you hit second and then tangent, and it'll give you that tangent to the -1. And then I'm literally going to type in 20 divided by 83 as a fraction. So if I round it to one decimal place, I get that theta's angle measure is 13.5 degrees. So just a little refresher on some of the things we've talked about so far this unit. All right, so this slide has a few different kind of vocabulary words. So initial side is a ray, so the side or ray of an angle that begins at the origin and extends to the right. So this is your initial side, always and forever, okay? Starting at the origin and extending to the right, okay? The terminal side is the other side of the angle other than the initial side. So like in this first case right here, there's your terminal side. Don't forget you can have, like in this one right here, your initial side is right here and your terminal's over here. Okay, so just keep that in mind that that can change a little bit. Now, coterminal angles are any two angles drawn in standard position that share a terminal ray. So meaning, for example, so here's an angle right here. In fact, I want to change my colors real quick. So here's an angle right here that has that ray. I could also do an entire circle around, and then they would share, those would be coterminal angles, okay, where they share that same terminal ray. So it's almost like you can go around an entire circle and then add that little piece, basically, okay? And then reference angles are the positive acute angle formed by the terminal ray and the x-axis. So you'll notice that all the reference angles in all these cases are notated by this symbol, and I've kind of mentioned this before. This is beta, so it's like capital B in Greek. So for example, let's say you look down at this one right here. Notice how theta is this entire angle going all the way across. Okay, so we're saying, all right, well, what's the acute angle formed by the terminal ray? So using kind of color coding, there's my terminal ray, there's my initial ray, okay? And we're saying, well, what's the reference angle? The reference angle is just this little piece right here, this beta right here. So we're going to talk about that more throughout this lesson today. For each of the following angles given by the Greek letter theta, draw a rotation diagram and identify the quadrant that the terminal ray falls in. So remember quadrant, if we go back to here, quadrant 1, 2, 3, and 4. Remember we start with this one because it's the most commonly used one, and then we go counterclockwise to label the other guys. So take a minute and pause on this page and practice drawing out these pictures, and then we'll talk about your answers. You can unpause the video when you're ready. All right, so this first one, 145 degrees, that's going to be right about, so if half a circle is 180, 145 is going to be right about here. Okay, So this is the terminal ray, and so that means that's going to be in quadrant 2. So if I do 320, 360 is an entire way around. So 320 is going to look something like this. So that terminal ray right here is in quadrant 4. Okay, 72 degrees. That's going to be in quadrant 1. So these go pretty quick once you get the hang of it. Negative 210. Don't forget that a negative angle measure actually goes clockwise. So 210 degrees I know is more than 180, but it's not quite to give me the 270. You go all the way around. So negative 210 is going to go to right about here. Notice how I'm not being super picky about exactly where it lands, as long as you know. Okay, so that's in quadrant 2. All right, 250 degrees. That's just before 270. So here's 90, 180, 270's all the way over. So something like this. So this one must be quadrant 3. Negative 310. Again, we're going to go clockwise. So here's negative 90, negative 180, negative 270. So something like that. So the terminal ray is in quadrant 1. Ooh, 460. Okay, so that's 360 degrees plus another 100. So here's 360 plus another 100. So that terminal ray also lies in quadrant 1. And then last one, negative 400. So remember, you're going clockwise when it's negative. So here's 360. So plus another 40 degrees. So something like that. And that terminal ray lies in quadrant 4. Okay, just to give you some practice with the 4 different quadrants and also the positive versus negative degree measures when we're looking at a coordinate grid. All right, give a negative angle that is coterminal with each of the following positive angles. So remember from our vocabulary, coterminal meant basically the equivalent angle that shares that terminal ray, okay? So for example, all I'm going to do first, you guys, is I'm just going to draw these out, okay? So 90 degrees is this guy right here. 330 starts right here and goes all the way around almost to like right about there. That's 330. 120 is something like that. And then 210 would be, here's our initial, so maybe like something like this would be 210 degrees. So I'm doing that all in black, and now I'm going to switch my colors so we can talk about the coterminal angle and really what that means if you're still kind of confused. So that means that I still want the same exact terminal line, meaning this is always your initial side, no matter what. Does not matter what angle we're talking about, whether it's coterminal or reference angle, doesn't really matter, okay? So basically what I want is if 90 degrees was going to the left and this was the terminal ray, I essentially want to say, okay, well then what's this degree measure right here? So I know it's going to be negative because I'm going clockwise, and I know it's going to be negative 90, 180, 270. So negative 270 degrees is the angle that is coterminal with positive 90 degrees. That's kind of how that works, okay? So this one right here, this is a little bit different for letter B because 330 goes all the way around. So I'm actually looking for this guy right here. So if 330 went all the way around, that means this is the other 30 degrees. So my answer would be negative 30 degrees is that coterminal angle. Okay, if this guy is positive 120, I want to go all the way around the other direction. So again, I know it's negative. And I could just do 360 minus 120 to kind of help me out. And I get negative 240 degrees. Last one. This time I'm going to go around this direction. So 360 minus that 210, and that gives me negative 150 degrees. So it's almost kind of like it pairs with it. So here's what question exercise number 4 is getting at. Coterminal angles drawn in standard position will always have measures that differ by an integer multiple of, and the correct answer is 360. If you notice, if we go back to these questions we just did, okay, 90 minus negative 270 gives me 360. If you do 330 minus negative 30, you get 360. 120 minus negative 240, 360. And I think you see where I'm getting at with that, okay? So you can actually use that to your advantage when you're trying to find coterminal angles, especially if they give you some that are a little bit more complicated than the ones we did. All right, for each of the following angles beta, draw a rotation diagram and then state beta's reference angle. So let's do the first one together so that you have more clarity of what the reference angle is. So we're learning two vocabulary terms today. The coterminal angle is pretty much going the opposite direction. What's the angle that almost like partners with the other one, basically, okay? The reference angle is going to be more so what we use in trig. So for example, if I were to draw 160 degrees, I'm going to draw it in black because this would be like my first step. So here's my initial ray, and my terminal ray will be over here somewhere. Here's positive 160 degrees. Okay, so what I want, the reference angle, is the angle between the x-axis and the terminal ray. So in this case, here's the x-axis and here's the terminal ray. So I want, what's that angle measure right there? All of your reference angles are always positive. So even if like the direction, you know how in the past the direction mattered, am I going left, am I going right? You do not necessarily have to worry about that. You just need to know what's the angle measure. So if half a circle is 180, then part A must be 20 degrees. Go ahead and pause the video and try these other ones and see how you do. All right, so if 300 degrees is going around like this, my reference angle is going to be this part right here because I want between the x-axis and the terminal angle. So this degree measure is going to be 60 degrees. Okay, if I do the same thing with 210, you might be getting to the point where you don't even actually need a picture anymore. It's completely up to you. Okay, I just want this piece, this reference angle, x-axis and the terminal ray. So 210 minus 180. That's going to be a reference angle of 30 degrees. Okay, I'm going to skip around a little bit. Let's just do one that's negative just so that you get an idea of what that looks like. So let's do negative 280. So that goes around this direction. So negative 280 is like right about here. So if you're doing this one, your reference angle again is the x-axis and the angle. So it's like this guy right here. So if all the way around is 360, I'm going to do 360 minus 280. This angle of reference, this reference angle right here, is 80 degrees. Okay? You'll get more practice with this on your homework too. All right, last couple questions, things to think about. Which of the following angles when drawn in standard position would not be coterminal with an angle that measures 270? So here's my thought. Remember how we said coterminal angles usually differ by 360 degrees? Okay, well, if I do 270 minus negative 90 in my calculator, I get 360. So I'm thinking, oh, those could be coterminal. Okay, what if I do 990 minus 270? I get 720, which I'm thinking, oh, okay, no big deal. But 720 is actually 360 times 2. So that's a multiple of 360. It doesn't work, right? So 630 minus 270, I get 360. So I'm thinking 720 works, okay? If you don't believe me, if you measure 270 degrees, that's going to be right about, in fact, actually exactly right here, okay? Notice how that's the same as negative 90 degrees. And then if you keep going around and try to find all the other options that could go with it, 720 is the only one that doesn't work, okay? All right, which of the following angles would not have a reference angle equal to 30 degrees? So you just draw out your picture, okay? If I'm doing negative 30 degrees, that is its own reference angle, right? So it's definitely not that one, okay? If I do 120, 120 degrees is going to be like this. Well, if the whole thing is 180, 180 minus 120 is 60 degrees, so that doesn't work. 210 degrees is right about here. Well, if this is 180 and that's 210, okay, that gives me an angle of 30 degrees, so that's something, okay? So this one would not have a reference angle. So actually, the 120, I take it back, 120, that should be correct so far. And then negative 330, that